I'm Mr. Zambarano. I am the department chair for CTE and I teach technology education. We at the high school teach a curriculum called Project Lead the Way, and the first course that incoming eighth graders would take would be Introduction to Engineering and Design, and then from there they could take any of the other 6 electives within Project Lead the Way. There's Digital Electronics, Principles of Engineering, Civil Engineering and Architecture, Engineering Design Development, and Computer Science and Software Engineering. So an introduction to engineering design, students learn the design process and we teach them how to use a 3-dimensional software. We use Autodesk Inventor and we teach them basically drafting skills and then they apply those drafting skills to solve a problem through the engineering design process. From there, they can take an architectural path or elective the year after, and that deals with civil engineering and architecture, dealing with large buildings, bridges, so the civil engineering component, structural analysis of composites, the actual design of the buildings. Another elective is digital electronics, and that deals with binary logic. We deal with basic electricity. Another elective is Principles of Engineering, and that's really a smattering of all fields of mechanical engineering, from statistical analysis again. We do trusses and bridge building. We do properties of material. We do some again binary logic, and we do some programming of robotic components. Other courses, Computer Science and Software Engineering is another elective, and that is we start with some basic computer program softwares like Scratch, drag and drop programs, and then we move into Java and Python. EDD, Engineering Design Development, is a senior level course that once you've had 3 of the other Project Lead the Way classes, you can spend a whole year designing and developing whatever you want. And the goal is to go from concept to creation, and we really want you to build a product, create a product, go to patent, and it'd be great if some students made some money in the process. Car care is for students with a driver's license, and anyone with a driver's license I feel should take car care. People say, oh, I don't think I want to take it because it sounds like it's too mechanically inclined. It's really to be a better automotive consumer. So everybody should really take the course, learn a little bit of safety around the car, how to change a tire, how to change a battery, jump start a battery. These are things that are going to happen in your lifetime. So it's really just general knowledge and being a better consumer around the automobile. People think, oh, I have to be really good at math and science. That's part of it. That's not the whole picture. People that are good in art and great in design do very well as another great part of engineering, as a design factor. Basically, students are applying knowledge that they've learned in our courses as well as their other curriculum, what we call the core curriculum classes. And it's a great opportunity to apply those skills, the knowledge learned in those other classes, to an application. We have real-world applications from 3D printing, digital electronics, right? So you're doing algebra in math class, and then in digital electronics we use that algebra to solve problems, to run a breadboard.